Okay, great. Paul, how are you doing?
Pretty good. How are you?
Great. All right. Good afternoon, everyone, ladies and gentlemen. Great to have you all here. We're not going to waste much time. I will quickly give a brief bio of Dr. Paul and also invite him over to speak to us on the subject for today. So let's see. Dr. holds a PhD in computer science from MIT. But before I continue, let me chip in that the whole meeting is being recorded, and we hope to share the video with you all after the meeting, all things being equal. All right, so Dr. Paul Azunre holds a PhD in computer science from MIT and has served as a PI on several DARPA research programs. He's the founder of Algorithm Incorporated, a research lab dedicated to advancing AI and ML and identifying scenarios where they can have a significant social impact. Ladies and gentlemen, Paul also co-founded Ghana NLP, an open source initiative focused on using NLP and transfer learning with Ghanaian and other low resource languages. Right. So he also serves as a director of research at Dun and Bradstreet, a company helping businesses manage supply chain risk and other business analytics challenges. He's the author of the recently published book, Transfer Learning for NLP by Manning Publications. Ladies and gentlemen, we have here with us Dr. Paul Azunre. So you're welcome, Paul, and it's over to you.
All right. So thank you so much for having me, and thank you for that very nice introduction, Emmanuel. I'm going to share my slides now and start the talk. So I hope you can see my slides. Please confirm.
Yeah.
Yep. Okay.
Yeah.
You probably can see other things. Let me get rid of this. All right. So, hi everybody. Thank you for coming to this webinar. My name is Paul Azunre, and I'm going to be talking about this transfer learning for NLP subject that I'm involved in. I was asked to give this talk to give you a sense of the kind of interesting things happening in this area, so that maybe if you're interested, you can get some ideas about what kind of things are going on and what you can contribute, perhaps. So in particular, I'm going to be talking about, I'm going to start with general transfer learning, for generally speaking for all languages, and then focus. I think somebody needs to mute themselves. Let me.
Please mute your mic.
Yeah.
Yeah. Joshua, mute your mic, please.
Okay. So I'll be talking in particular about applications to multilingual problems and particular Ghanaian problems and African problems, because that's what we should care most about, since it's our society. And in general, the talk is going to be divided into these three groups. This is some version of the talk I gave at Texas Data Day a few days ago, actually. I've modified it slightly. The first part, I'm going to talk about the transfer learning for NLP history. So how did this happen? Which models kind of led the way, and what were the key ideas, just so you can understand why this needed to happen, or why why the field moved in this direction. And then I'll talk about the work Ghana NLP is doing to kind of apply some of these concepts to Ghanaian languages and other languages in Africa. And then if there's time, I'll talk about like an application area, so business analytics, just to give you a sense of something different and applied you can do with this stuff. So without much ado, I'm going to proceed and tell you a bit about me. I like to do this because there are a lot of different opinions in the field, and depending on what you prioritize, whether you are a theorist, whether you are a more applied person, and so on. So I like to give this preview of who I am, just so that you can evaluate my opinions in the context of that, right? So I came out of my dissertation, which was done at my PhD dissertation, which was done at MIT, was about building solar panels, more efficient solar panels, so reducing reflection from a solar panel. It turns out you can write, an optimization problem for how to reduce reflection from a solar panel by varying the thicknesses of the various materials you put on top of it, and varying what you put there, right? So which material you put there, you can change the character of it, right? So that's an optimization problem, and we did that and we built a device. So what I care about is that's kind of illustrates kind of the things I care about. I care about applications of this applied math ideas in the real world in a measurable way that can improve life, right? I care about more than, say, theory, right? Or like so theory of deep learning or something like that. That's very important, but that's just not what I do, right? So, and in general, I think in the industry, of course, it's very empirical and it's very applied. And so that's where I work. And so, of course, that's what I care about. After my PhD, I did some work at Oracle for designing chips. So there are a few companies in the world that design their own chips. Oracle is one of them, Intel and others. There are a few other ones. But basically, you have to figure out how to put the various elements of the chip around the board and to minimize certain undesirable things about it, like delay when the signal moves from point A to point B, right? There's a way you can organize the chip to minimize that. And so this is kind of like, again, an optimization problem. So I came out of applied optimization. And then I found myself at DARPA working on automatic machine learning. DARPA is, likes to call itself the place that the internet was invented, right? So it's like a lab that the US government, it's the work I did was open source, but they definitely have classified work as well. And basically trying ideas that they found ideas that are kind of beyond what currently is mainstream, just to search for breakthrough innovations. And a lot of it fails, and once in a while you get internet or something else. Like a lot of things that you're using actually were created there, you might not even know. Like memory foam, for instance. You might not know that memory foam was designed for as people go to space, cosmonauts, astronauts. So for comfort for them, right? And then, but it didn't work there. Ended up working for humans. So now we sleep on memory foam here, right? So this kind of stuff, which is a very important to drive innovation. So I was there working on automatic machine learning as part of the company called New Knowledge. And the idea was to create tools that could minimize the tedious things you do as a data scientist, right? So the things that you don't really enjoy that much, like cleaning data, the repetitive tasks that maybe there's a way to automate them, all right? Or maybe even in the extreme case, maybe even the system can just look at the data and propose some problems or models or model framework that can be applied to the data and then even solve it for you, right? So this is kind of like Star Trek future, where the machine, you don't even have to think about the machine learning problem. That's what automatic machine learning dreams to achieve. You don't have to think about the problem. It will decide, the system will decide for you the right architecture. It will decide for you, the hyperparameters, and run the problem and give you the solution. All right. So this is the dream, but of course, in reality, right now, automatic machine learning is automating tedious parts of the process. Right. So this is what I was researching. I've also started a company called Algorin, which has a branch in Ghana. And the idea is, with that, I started it after my PhD to try and kind of look for initially applications of the solar energy stuff that I'm showing on this screen. But later it evolved into the applications to Ghanaian languages that we are going to talk about. So this is kind of my journey. This is the name of the program I was working on at DARPA, Data-Driven Discovery of Models. All of this stuff is open source. If you Google it, you can find all the tools that we worked on. That's a great thing about some certain things done at DARPA. In particular, I worked on this task within this context of automatic machine learning, right? One of the tasks I worked on was figuring out how to automatically type data so that the system will know what to do with it, essentially, right? So most of the data that the system would see would be tabular, right? So this, like a lot of the time, the data we see as data scientists is tabular, which I'm showing examples on the screen, right? There's a table, one table maybe have customer ID, the other, one column has customer ID, another column has sales, corresponding sales, another column has some comments about the sales, right? And you may, a data scientist may run some maybe information extraction on the comments to understand what the data is about. They may use the sales to run a regression of some sort to predict future sales or something. Or they may try to, classify the customers into groups or something like that, right? These are some things that a data scientist might be interested in doing with data like this. But in order to decide which things can be done, right, you implicitly as a data scientist know that, right, you are going to use floats for regression, right? And maybe the customer ID, the categorical variables are more suited for categorization or classification, right? And of course, the text column is suited for something like summarization or other type of NLP analysis. So knowing the type of the column is very important for figuring out what to do with the data. So my task was to do that typing. So in this case, of course, column 1 is an integer or a categorical, column 2 is a float, and column 3 is a text, right? So this is what my classifier was supposed to be able to do for a collection of types. And we approached it using this architecture we called it Simon. Essentially, don't worry too much about the details. I'm not trying to scare you, but there are some building blocks here that are going to be found in a lot of neural nets. And just to break it down a little bit so you know what goes into it, and it's also going to give you intuition as to some of the, why we did all of this stuff works or why it's done, right? So just bear with me for a second. There is a convolutional neural net at the beginning of this architecture. It's followed by a bidirectional LSTM. I'll explain what that does. And a couple of them, whatever. There's a bidirectional LSTM after some convolutional neural nets. And then, of course, the typical classification stuff at the end. So this is, we call this architecture Simon. And when we applied transfer learning in this context, it was to address the data requirement, right? So what happens is that there was not a lot of training data that we had for the problem we're trying to solve, but we were able to simulate, right? You can simulate, integers and random texts, and you can simulate float numbers, right? Or city names, latitude, longitude. You can simulate that, right? It's not going to look exactly like real data, but it's going to have a lot of the same features, right? And so you can, when you simulate that data, you can train your model on it. And then once you have that model, then you add a little bit of real data at the final step, right? We call that process fine-tuning. All right, so this is done in order to minimize the requirement of real data that you don't have, right? Because it's very expensive to create real data, right? So we use transfer learning in this context, and we use this idea from which has been popular in computer vision for a long time, and I'm showing it on the slides. So you know, in computer vision, nobody trains anything from scratch, right? What they do is there's a data set called ImageNet, decades ago created. They train models on that. That model has some general knowledge that's applicable to everything. And then they fine-tune or transfer that to a very specific scenario, like in this case, lung cancer detection. And even though lung cancer was never in ImageNet, it was never trained to detect lung cancer, but it has learned something general about vision that you can, you know, with just a little bit of real data for your scenario, you can very quickly build a classifier, right? So this has been known well and applied heavily in computer vision for at least a decade before NLP caught up. And of course, when we say NLP, we are talking about processing of human speech and texts, audio, it could be audio, all of that falls under that. So, you know, and when you are doing this fine-tuning process in computer vision, and computer vision is mostly built, in the beginning at least, was built on convolutional neural nets. What you did is you had, you know, you increased the number of layers that you would unfreeze on your real data until, you know, the performance began to drop. The reason you wanted to do that is because the features towards the output of your neural net, right? So towards the part which is classifying images into groups, it's going to be very specific to your classes, right? So it's going to be very specific to your problem. Whereas the layers that are further away and closer to the input, those are more general things, or those are layers that encode more general things. So for instance, detection of edges, right? That's something very general, and it has been found that the layers closer to the input are the ones doing these general things, right? So this is why in computer vision, they unfreeze or train only the layers closer to the output and not the ones closer to the input. And you train more and more until performance doesn't improve, right? So this is kind of how it is done in computer vision, and we're able to do this in NLP. This was 2019, so this is just 3 years ago. The field has grown dramatically since, and it's extremely active. Probably the most active. NLP is the most active in machine learning right now, I would argue. So around the time I stumbled that we did this, there was the revolution in NLP on transfer learning was happening. And it started with this model called ELMo that I will get into, that looked very much like Simon. So essentially, I personally, through this process, stumbled on this revolution that was happening in NLP and got in very early. At the time, there was no book where I could go to and, you know, go through the key ideas, the ones I'm discussing with you. You had to go to blogs, you know, read over here, read over there, read the paper, right? It wasn't all in one place in a nice, easy to consume way. So I felt like writing this book at the time, and it came out last year now. So all the code is free on Kaggle. I'll share the link later. So please check it out. The code is free, and you can just run it without installing anything. All the key ideas, you will learn them. These are the kind of tools that are used nowadays in this related tasks around here. And of course, TensorFlow, PyTorch, Fast.ai is one that fewer people know about. It's very useful as well. Hugging Face Transformers is probably the biggest one now. You probably have heard of it if you've done NLP. Keras, of course, is still very useful. GenSim, scikit-learn, the typical things. So let's take a step back for 1 second and try to define essentially what transfer learning is. I've been kind of implying what it is, but now let's define it through an example. A good example I like to use. So if, let's say, you knew how to play the piano. Say you're a musician and you know how to play the piano, and someone asked you, you had to learn how to play the organ, right? Which is it's a similar instrument in some ways, right? With the keys and stuff. It's different, but it's similar in some ways. So you would expect that a piano player would be able to learn how to play the organ easier if they knew how to play the piano than if they didn't know how to play the piano, right? So there's some knowledge about how to play the keys that's likely to transfer between those two scenarios, which means the amount of data, let's say the amount of training time that this person will have to go through as a musician is going to be a lot lower once they already know how to play the piano. All right, so when, as human beings, we reuse knowledge, we don't have to start every single time from scratch like we're newborn babies, right? We know something, we can adapt it to a new scenario. And so this is what transfer learning tries to describe, this process of carrying over that knowledge. And it just turns out that in NLP, although of course we were using embeddings for a while now, we've been using embeddings, that's definitely transfer learning. Just the complexity or how sophisticated the methods became very different over the past few years. A lot more sophisticated. We understood it better, how to do it. And this gave rise essentially to a whole new paradigm of how to solve problems in the space. So that's what transfer learning essentially is. Don't learn things from scratch. They try to, one way of classifying different types of transfer learning is by this criteria. You transferring between different domains. So an example of different domains might be transferring between Amazon review classification to reviews on target.com, or to maybe reviews of movies on imdb.com, right? Different, kind of a similar task. It's the same language, similar task classification, but the data is different, right? You may even have the same classes on Amazon and Target, but the kind of language that people use and different things are going to vary, or like Facebook reviews or Yelp reviews, right? Or things people say on Twitter. Different types of data. You can't just take one and apply it and expect it to work as well in a different domain. But you can, if you adjust it, right, in that scenario. So this is what domain adaptation is. And then if you are transferring between different tasks, let's say between classifier and summarization or something like that, or question answering, different tasks, people call that multitask learning. And then different languages, which is the one that we really care about here, is cross-lingual learning. So transferring between, say, English and Twi. Right, that would be cross-lingual learning. So we care about cross-lingual learning. That's kind of the thing I work mostly on. Just to make sure we're all on the same page, so let's talk about embeddings. Right, so in NLP, which is the processing of human speech, one of the key ideas that you learn when you start with the field is, an embedding, a representation of text, right? If we want to turn text into numbers, a vector of some sort, that a computer can easily manipulate, right? Add, subtract, and so on, in order to, extract information from the text, right? And this representation, you can't just use any representation, right? The representation has to be meaningful in some sense. And so this representation, a representation that captures the linguistic relationship between different texts, right, has to, that's something useful. It can't just be random numbers. And so word2vec was one of the early ones, and fast text is another version of that, which uses, which does the same thing on a sub-word level, whereas word2vec works on a word level. So all word2vec essentially is constructed in a way that if two segments of text mean something similar, or the meaning between them is similar, they'll be closer together in the space. And if the meaning is very different, it will be further away, essentially. And so you can see, but not just that, also the distance between words, right, that are different meaning is comparable if, for a different collection of words, if the difference in meaning was similar, the distance would be the same, which is, just to give a good example, a clever example, or example that's heavily used, right? The distance between man and woman in this space would be similar to the distance between king and queen. All right, so that property allows it to, do analogies. For instance, if king is to queen, right, then you measure the distance between them. Then man is to what, right? You take man, you add the difference between king and queen, and you should get the one for woman, right? So it allows you, these properties allow you to do arithmetic, essentially, to extract meaning and do sophisticated tasks in NLP. So that's embeddings. If you know about embeddings, you can do NLP probably. You can start at least. Now, there was a problem with these early embeddings, word2vec, fast text, Glove, in that they couldn't do disambiguation. In some sense, they were static. And this is the example I tend to use to illustrate that idea, right? So let's consider two sentences. He examined the cell under the microscope, and he was locked in a cell, right? The word cell here means two different things, and I've pictorially represented the meanings, right? In one case, it can mean a jail. In another case, it can mean a biological cell, right? So it turns out that word2vec, the way it was trained, it couldn't consider the context, so it always gave you the same vector, regardless of how the word was used. So in this case, it would give us one single vector, regardless of whether it was in sentence A or sentence B. And that vector was some kind of average of all the meanings of the word. So it was just an average representation. You couldn't break it down by context, right? So what are we talking about? Are we talking about biology? Are we talking about criminal justice, right? So we needed models that could address this. And this is ELMo, the model I mentioned before that was similar to the Simon that we worked on, which how I entered this field. And it also used exactly very similar components, right? It used the character level neural net first, and then it used the bidirectional LSTM. Now, the bidirectional LSTM is a nice way to learn about this, how this model started addressing this issue, right? So a bidirectional LSTM, if you look at the middle layer, you will see it's composed of one direction, a layer that moves in one direction, and a layer that moves in another direction. So in terms of the examples we saw before, right, that would mean starting at the beginning of the sentence and moving to the end of the sentence, looking towards the end of the sentence, and also starting at the end of the sentence and moving and looking at the beginning of the sentence, right? So one layer does one direction, the other layer does the other direction, right? And then overall, these two representations are put together to give an overall representation, right? But what this ability to look in both directions means is that you can look from the word cell, essentially look around the word at the rest of the sentence and work out the context. So for example, if you were trying to evaluate the embedding for cell and you looked towards the end of the sentence, you would see microscope and you would know that we are talking about biology, right? Or in the second example, if you were looking towards the beginning of the sentence, you would see locked and you could deduce that we are talking about jail, right? So this kind of course, oversimplification, because the neural net is doing this deduction using its neurons, and I can't, that's not how it reasons about it, right? But essentially, that's the intuition as to how this bidirectionality enables you to handle context. So ELMo was the first model to achieve that, or the first big one. There may have been smaller ones before, but at least the one that made the waves was ELMo. And in addition to being able to handle context like this, what the model was essentially trained on a very huge corpus of books, or a huge subset of the internet, right? So they trained it on a lot of data in order to try and get this general knowledge about NLP that could transfer to different scenarios, right, that we talked about. Another method that I consider important is called ULM-FIT. It's not as popular now, but it introduced some key ideas on how to perform the transfer process, right, the fine-tuning process we're talking about. So after you train on, let's say, simulated data, fine-tuning it on the real data, right? The problem with the fine-tuning step is that there's something called catastrophic forgetting, which means you're going to forget everything from the first step, at which point why are you doing it, right? And so this method came up with a number of techniques that are implemented in a lot of methods today for reducing that problem, that forgetting problem. And so one of the things they suggested is we should use slanted triangular learning rates. So I show the diagram here. What that means is that if you want to learn at the rate of 0.01, your neural network, right, don't just start at 0.01 at the beginning, right? Because that's at the beginning, you could forget everything you know. But ramp it up slowly until the maximum rates, and from there bring it back down to 0, right? So you're not even keeping it constant there. It's like a regime over time. Now, you probably, if you've trained neural nets, you probably are not thinking about this explicitly anymore, or maybe there's a parameter called warm up or something like that you're adjusting. But essentially, other methods like Hugging Face transformers has implemented this behind the scenes, right? Another thing they recommended is something called gradual unfreezing, which means if you are unfreezing your network, remember we talked about training more and more layers closer to the output on the real data, like in computer vision. So these people said when you're doing this learning process, let's say you found that the 3 layers, unfreezing 3 layers is the ideal scenario. Don't just unfreeze the 3 and train. Instead, unfreeze 1, train on that, take that model, unfreeze 2, train again, take that model, unfreeze 3, train again, right? So essentially, in some sense, just like this triangular learning rate, you don't want to just do the thing at once. You want to just make it more gentle and smooth it out, right? And then discriminative fine-tuning just said, define the schedule for how you should vary the learning rate as well across the different layers. So not just in time, and not just in the unfreezing, how you're unfreezing, but also vary across the layers. So the deeper you get into the network, the rate changes. All right. So these are kind of like some schedule they defined to reduce catastrophic forgetting. And this was a, this moved the field forward a bit. And then this idea of self-attention came up. And, there's a lot of math around it. It looks scary. But really, if you think about it, it's performing a weighted average. It's defined a vector representation for every token in a sequence, and it's performing some kind of weighted average across all of them. And this weighted average performs the same function as the bidirectional LSTM that we just talked about. So in performing this weighted average, it's able to look in all directions around any token you're interested in the text, see what the context is, and make the deduction. And also the way this weighted average is constructed makes it extremely amenable to scaling, computational scaling, right? So remember, we are training, these models are now being trained on huge data, right? Big, like the internet, right? And so being able to scale a model is very important to being able to do it in a practical amount of time. So it turns out that this weighted average self-attention scales a lot better than bidirectional LSTMs. This is the reason why the model that incorporates it, called a transformer, has become the most popular architecture in NLP, because you can scale it very easily compared to the LSTMs, which are recurrent neural nets. So then this model called BERT came along. Again, I don't want you to get scared by these diagrams. So essentially, it builds on self-attention. If you look at this long enough, it makes sense. It's not that complex, but I won't get into it. What I will get into, though, is how this model is trained, which is essentially by filling in the blanks. Remember when, as a kid, they gave you a piece of paper and then they blanked and said, put the right word in there, right? Essentially this on all of the internet, right? So what they do is they drop some words in text that they already have, and then they try to predict those words back and try to train the model to be able to predict those words back, essentially across the whole internet, right? So it turns out that this task, first of all, the reason what this realization that we can do things like this did was make it very easy to generate the data, right? Because we already have the text. Randomly dropping some words, that's just a script, right? And then we have the data and we know exactly what we're trying to predict, which is the original text, right? So it's an extremely easy metric to implement from a data perspective. You don't have to create any data. You just throw your internet on it. You got the internet data, throw it at it, right? So this is essentially how people started. There's some dangers with doing it that way, and we'll get into that. But essentially, yeah, you're filling in the blanks. This is how this model is trained. This made it very easy to train them. The model was called BERT, after the Sesame Street character. And then we had the causal version of BERT, if you like, or the causal version of transformers. The causal means it was trained to predict the future or the next token. Whereas filling the blanks that we looked at before on the previous slides, it doesn't have a sense of the future. You're just predicting on the whole text. In this case, you're predicting the future tokens given the past tokens, right? So it introduced a sense of causality in order to be able to predict and generate text, right? So that's what GPT is, a generative transformer. You probably have heard about it. It's been in the news. It will continue being in the news for a while. People are excited about what it can do. So the latest version, GPT-3, which actually was released last year, it's pretty impressive, the kind of text it can generate. And here, I show an example. I only gave it a prompt. And by the way, I'm using the open source version, which is not GPT-3. It's from Eluther AI. It's an organization that tries to build, because GPT-3 is a paid service. there are some organizations trying to build open source versions of them, and Eluta AI is one example. You can go to that link and try it right now for free. But essentially, all I gave it was the Ghana Data Science Summit is going to be, and I told it to finish, right? And on the right, you can see what it generated. And if you read it, take a second to read it, you will see that the code is, the text is impressively human sounding. Right? Almost like it's grammatically correct, because it has seen a lot of maybe websites about Ghana. So it's able to extract some stuff about Ghana, say some stuff about Ghana. It has seen lots of blog posts about data science. It knows some things to say that are relevant. But if you keep reading closer, you also see that it's making a lot of logical sense that doesn't make, no sense sometimes, or a lot of the time it doesn't make sense. Let me. Anyway, I wasn't able to find any nonsense in this one, but if I encourage you to try it. It does generate nonsense, and you will see articles in the news about, oh, the AI is sentient. Oh my God, this is kind of trendy right now. So just be careful, because I definitely, if you use the tools, it's clear they're not anything close to sentient. There is a lot of hype in AI, right? Because there's a lot of money being poured into the field, and so just be skeptical of claims. Don't just take those claims. And obviously, the people selling the news, some of them at least, they profit from like fantastic claims that are not true, right? So there's definitely a lot of news that you see. Dig deeper, and you find that there's a lot of nonsense. So yeah, I just want to say that a lot of hype, and it's important to be able to distinguish the hype from what's real, because that's how you're going to do impactful things with it, and also be aware of the dangers. So there are other types of tasks you can perform beyond generating text, right? You can do sentiment analysis, and this data set called GLUE in English provided a lot of different data you can train your model on in order to perform different tasks. So whether it's comparing questions or comparing similarity between text segments, or question answering, or textual entailment, and those sorts of things. So there are data sets, standardized data sets that are used as benchmarks for algorithms. GLUE is one of them. Now we have super GLUE, probably more by now. And here's an application of GPT, which is interesting. All right, it's called GitHub Copilot. They recently opened it to the public. You can now purchase a product that will help you, essentially help you write code, right? So if you describe in the comments what you need a function to do, like in this case, function to unzip a file, function to zip a file, or what's the next one? Yeah, it'll just generate it for you, because they've trained it on open source text. And so it maybe has seen this function before. And so it's essentially doing some version of the thing you do when you go to Stack Overflow to pull text, to pull code, right, for your problem. Essentially, some kind of faster, more effective way of doing that. GitHub Copilot, that was an application of GPT. So the models are not sentient, but they do useful things, right? This is another interesting example, which is, now we are getting to cross-model examples. So we are matching text to images, right? So the model called DALL-E was trained on a data set of images and text, right? And so it's able to, from a text description, generate an image for applications in art, for instance. And here you can see generating some examples that it definitely hasn't seen before, like a snail made of what? A snail made of lettuce or something like that, which is definitely not a thing it saw in the training data, but it's able to generate something that's plausible. If there was such a thing, it might look like this, you know? So it's almost like the model has imagination or something, but that's just like a visual representation of generalization, of the idea of generalization in machine learning. That's how I like to think about it. But definitely it creates the illusion that the model has imagination, right? And I guess someone will say, but is the imagination that humans have, isn't it also an illusion, right? And then we get into philosophy. I'm not a philosopher, so I'll move on. DALL-E 2 has improved a lot in quality. So now they're training on a much bigger data set, much more refined text and so on. And so you can immediately see, whereas the previous one was kind of like a joke, now this is becoming serious, right? Look at the image on the right. It's photorealistic. It's like a photo, right? But that dog doesn't exist. It just made it up from a text description. So I think they said a portrait of a mastiff or something like that, and a photorealistic photo image of a mastiff. And the model generated that. The image on the left, the bear, I think the prompt was bear in mind, which is kind of funny, play on words, right? The bear is in mind. Yeah, so some concepts there that an artist may not have even thought about, right? You see the bear's mind, and artists do play on words to create concepts, so that's very interesting. And you can actually go to their IG account and follow them, Instagram. I follow them. It's very remarkable the kind of images it's able to generate. Now, all of this advances has been driven by a dramatic scale or increase in scale of models. So whereas the early models like ELMo, you see almost close to 0 billion parameters, right? Then it slowly started creeping up, and then GPT-3 took it to 175 million parameters. Huge model, huge model. Millions of dollars to train it once. Or at least when you train it, and then you're doing the hyperparameter search, you have to do it again and again and again, right? Millions of dollars are just burnt to train a model. And all of this investment has been made, essentially, well, not all anymore, but most of this investment has been made in English, some European languages, some Asian languages, right? The African languages are not, at least in the early gold rush that happened with these models, we're totally left out of it. So I just showed the slide just to show you the amount of investment that's being put into this field, and it's not towards the things that are relevant to us directly. There are also lots of dangers in this trend. So we mentioned millions of dollars being maybe perhaps poured in a non-symmetric way or non-fair way distributed across the world, whereas definitely say the emissions that come in from the supercomputers running this code is definitely being distributed around the world and impacting the people that it doesn't serve, all right? That's like a fairness issue. We said that everything has been done to enable big data to be thrown at these models without much thought about what's in there, right? And so, of course, on the internet, we have all sorts of toxic language, whether we're talking about racism or some kind of ethnic hate or, whatever you can think about, right? Sexism, right? It's on there. So you're training your models, and some aspect of the model learned that negative stuff. So these are all risks. I encourage you to look into this paper that outlines some of these numbers and risks. So when a number of colleagues and I were working in this field, we saw this uneven distribution and the lack of tools for Ghanaian languages. We felt we needed to do something about it, right? And so, of course, the difficulties in this space mostly have to do with low amount of training data to train the models. All right, so for a language like Frafra, where my dad and I am from the Upper East region, there may be one dictionary of Frafra. There are not that many web pages. So where do I get the data, right? It's very difficult. Even for a language like Tree, when we started out, there were some religious sources, which is a nice starting point that you can use. The idea of transfer learning to, learn, you can learn on that first and then kind of train on real data. This is what we did. But still, apart from the religious data, there was nothing else. We had to create the data first, which takes a lot of money, right? It's hard to produce a high quality data set without investment, right? And it costs money because, a professional linguist rightfully should be paid fairly for their time, right? And if you pay them fairly for their time, it's very expensive, right? And so there are no funds. I would say Ghanaian government, some people may disagree, but in my opinion, Ghanaian government just doesn't invest in anything like this. So the Ghanaian government is not a good source for funds. The external parties, I will show you a diagram that complicates the issue from external parties. Okay. If you, at least at the time we started, if you looked at, say, Google Translate, you wouldn't find any Ghanaian languages. They've added Tree and ELMo now. Our model, Ghana NLP model, is better in the Tree at least. Even if you do find, so this raises the issue, that even if you do find the languages represented, the quality of translation may not be good. So I was surprised when we were putting out some of the news about our translators of what we've been able to achieve at Ghana NLP. I had people speaking Swahili approaching me and asking if they could, or if we could add Swahili to the app, right? And I asked them, but Swahili, Google has had Swahili for years. Why do you need it? But they told me it's not good enough in their opinion, right? So they just want it to improve, right? So even if these tools are handling some language, don't assume it's going to be very good. It can still improve. So this is what Ghana NLP is trying to do. In addition to just building tools that, like Google, I think we think it's very important that the gatekeepers of these technologies are the natives, all right? So Ghanaians should be the gatekeepers of Ghanaian culture, all right? So, and these tools are, in fact, huge gatekeeping, gatekeeping tools, right? So I'll give you an example. There is actually a very big data set of Tree available, but it's not free. It's available in the University of Pennsylvania, right? Some language department there has a huge data set of Tree, but they own it. In order for Ghanaians to use that data set to train tools for Ghanaians, we have to pay the University of Pennsylvania tens of thousands of dollars to use that data. You understand? There's nothing like that the Ghanaian government can provide, right? So even if I was being charged for this data, I would love to go and give it to the Ghanaian government so that the Ghanaian government could invest it into the roads, the schools, and so on. But instead, I have to give it to the University of Pennsylvania. For our culture, that makes no sense, right? It doesn't make sense to me, right? So I think we have to be the custodians of the stuff. We have to own at least an alternative, right? Of course, if Google releases lots of tools, it's good for all of us, right? But there should be an alternative that we are in charge of, that we define the direction of. So at the very least, that so that we can keep the other entities in this space honest, and additionally, that we make sure that we benefit in some way from this future, because this stuff in the future is going to be extremely powerful, and this technology essentially changes the society, right? So if you build a tool which accepts spelling errors, or you only have to, it only works if you spell things wrongly, then people are going to start speaking the language wrongly in order to use this tool, right? So you can actually change society for the worse if you're not paying attention to detail, right? And I feel like nobody cares about this stuff as much as we do, and so we should be in charge of it. So this is why Ghana NLP exists, and we've contributed some open source data sets. We try to build computational methods and build an ecosystem of people just working on this stuff, helping each other, starting companies, you know, academic careers, you know, some people going to grad school, right? So just an ecosystem, because that's how we take on the future. We've been, you know, lucky to work with some very good partners. Among them, Microsoft gave us some computing resources, which sustained us the first couple of years. That's how we trained a lot of our models. Here, I'd like to show the speaker count for the languages in Ghana. It may be outdated by now, but really the point here is that external parties don't care as much about our languages because the number of speakers is not large enough. If you read any paper in this space, nowadays they've started, there are lots of amazing work being done in Africa now, but you will also see there's an imbalance in which languages are being focused on, right? So obviously Google first added Swahili to their system, of course, the number of speakers, right? Yoruba, they would add Yoruba before they think anything Ghana, of course. Yoruba is what, 80 million people? That's more than Ghana, all of Ghana. So, of course, that's what they care about, because once they build that, they have a product 80 million people can use. Whereas if they build Tree, they're not even up to 20 million, probably, right? So these are the reasons why external parties don't care as much about our languages, because if you think about it from a profit motive, we don't really rank in priority based on the number of speakers. And even our own African researchers, when you read their papers, right, when they try to build like a multilingual model for African languages, you see them omitting Ghanaian languages because they used number of speakers to prioritize, and we are not up there. You understand? These are some of the reasons why we can't wait for some savior from somewhere to do this for us. We have to do it ourselves. Lots of reasons to do it. You know, I probably can skip the slide. You know that. You know, education, poverty alleviation, and all sorts of life-saving things we can do. So we've collected some data. We built some embeddings. We have a neural machine translation tool. We are about to put out the API for the neural translation tool so that you can begin to incorporate the translations in your own apps, right? For a small fee to support the research, you can start incorporating it in your own apps, and our ecosystem can grow. So this is our English tree data set that we built with support from Zindi. Zindi, GIZ was also involved. You can find this all open. I'll skip this procedure stuff. We built embeddings for tree. So we started with embeddings for tree. If you look closely, you will see words that have similar meaning closer together in this space. This is another representation of the same thing. Mawofo, Mami are close to each other. Papa and Mami are close to each other. So if you go through this diagram, you'll see that it has the right properties that we discussed before. You know, closer together, they're similar, they're used in the same context. Abuna, this is the Abuna model that I think you were talking about. The Abana is essentially BERT for tree. That's what it is. It's not the voice assistant. But it shares the name. So essentially, remember that cell example I gave? Now look at this tree example. The word so, right? Two different uses of the word, two different meanings. Exactly the same idea. This model was trained on JW300 data first, and then fine-tuned on some more real tree data. It's on Hugging Face repo. You can just copy and paste this code, and it should work directly for you. So you can try it. By the way, we are actively working on this stuff. So if I saw some members in the list of attendees, if this is something you want to work on, please join us. Kaya is another product that we have put out. It's a translator for Ghanaian languages. Now a translator for African languages, because our users started asking for more languages to be incorporated. It was the first neural machine translation app for tree, right? We were out a year before Google put out theirs, maybe more. It's very good now. Definitely the tree is incredible, I'm told. The other languages, it gets, we have also Dagbani, which also I've been told is very good. Nafi is on the call, he contributed a lot to that. We also have Ga, Ewe, and Yoruba. Like Yoruba does better than Google in the test that we did. Tree does better than Google in the test that we did. So it's a respectable app that competes and holds its own among the best apps out there in terms of quality. It can also do voice speech recognition. Here's an example of it working, right? You can also use it. It's on Google Play, it's on iOS. I hope you try it. You can go to translate.ghananlp.org. If you don't want to install it on your phone or you want to use it on a computer, you can just use the browser. If you do try it, let us know what you think. In addition to text translation, it can do speech recognition. So you can speak to the app and it will transcribe your speech into text. Let's say in tree, if you didn't want to type something, you can just say it to it. Then you can copy that text, you can translate the text, you can do whatever you want with it. And the reminder is that this stuff, we are building APIs. So if you want to build an app on top of this, so you have some idea that you need a translation for, you can use our API and not worry about the translation part. We have some, I like to give this example because it's a nice thought experiment. For now, it's a thought experiment. We are yet to demonstrate a lot of this, but we are working hard at it. The idea is, can we teach children to learn to read their native language first? So this is important. Why making an Asante kid learn tree first? Maybe they'll become better readers faster that way than if you make them learn English first, right? Because it isn't the language they use at home. So early reading maybe being done in their native language is better. And this is a nice technique for doing it, which relies on automatic speech recognition. And so what you do is, you bring in some visual cue like giraffe, right? You see that he's holding the giraffe. You bring the giraffe in and you say giraffe, right? And then the automatic speech recognition detects what you said and flashes the word for the kid. Like you see around his neck. So now the kid heard the word, how it said, they saw the visual cue, what it looks like, the actual object, and they also got the spelling, right? And so if you keep doing this, showing them different objects and saying it and flashing the word, they learn how to read it very early. So like a 1-year-old kid can learn to read using this technique. So this is kind of an experiment that we are working on. Very difficult to set up, right? There are lots of ethical concerns. Lots of the time, the school that you're going to try it in may not have internet. So you have to think about how to run these models without internet access, how to compress them, right? So model compression is important. This is not something that we've even started full-blown research on, but in terms of things that are interesting or could have a great impact, model compression, pruning, distillation, right? And generally putting them on devices so they can run directly, say, on the cell phone instead of having to communicate with some backend in the cloud, right? So some ideas for you. So I've been saying that funding is extremely difficult. I told you some of the reasons why it's extremely difficult. This is one thing we are trying to counter that. So funding the app itself, so it can keep running, the app, at least the ad-supported version is free for everybody. That costs money, right? We need to find a way to pay for that. And so we offer like a subscription to an ad-free version, very cheap, like, that's what, it's $10 a year. That's, I don't know, $1 a month. That's what, 7 CDs a month, right? We would argue that's a good price, but really it just supports of us. And the community has been supporting somewhat. It's not enough yet, but we hope it's growing. So that's one way we are trying to fund it. We've also recently, Google committed some money to support some of our data collection efforts. And we had another collaboration with Harvard that we got into, where we are working with some Kenyan institutions and some Senegalese institutions and professors in order to scale some of this technology, which has been successfully applied. At this point, more than 50 to 100,000 people have used this app, with very good reviews. So it seems promising. And so these organizations want to help us scale it beyond Ghana. So there are two efforts, right? We are also expanding across Ghana because we have to, our tree, for instance, doesn't split the different dialects, right? Fante, Ashanti, Bono, all right, the Ekwapim, it doesn't split them, all right? So at some point, it would be nice to handle every dialect separately. So we are working towards that. Ga, right, there's Dangbe, there's Krobo, which is kind of related, right? In the north, Dagbani, we have Dagbani, like Frafra or Gorne, Wale, so many different languages that we need to keep adding that will require creating data. And, what are the methods, right? So just to bring it back to the idea of transfer learning, what are some of the transfer learning methods that we're exploiting in this case? Remember, transfer learning enables you not to learn from scratch so that the amount of data you use is smaller, right? And we are talking about the funding issue, the fact that we don't have enough money to create big data sources. So these ideas help us reduce how much data we need. So for instance, I think most people do is they start with the religious text, right? The Bible, the Quran, JW300, which is a Jehovah's Witness collection of text, which happens to cover a lot of the languages we care about. Not all, but a lot of them are in there. So you start training your models on the religious text first. Of course, that can be your final model, but just as in the case of simulated data, it's a first step. Or the case of ImageNet, right? You start with that so that the model learns some basic things that you can then repurpose. And so once you have that model, then you have to, of course, collect real data that's representative, unbiased, trying to make it unbiased across, gender and stuff like that. And then fine-tune that model further on that. Hopefully that process will eliminate a lot of the religious bias that's in the model. That's one thing that we do. If we didn't do that, it would have slowed us significantly. It would have been a while before we could have put out any translator, right? So while we recognize it's not ideal, and sometimes you say this to people and they laugh at you, right? People who don't know the field, who are very opinionated, they will hear this and say, this is nonsense, right? You're training on religious data, this is ridiculous. Well, if you actually try to do this, you see that there's no other way. So, you train the model, you do your best, you add the warnings, and you make sure you don't deploy it until you've tested it sufficiently to make sure it's not something horrible. So that's what the approach we've taken. Another thing that can help is sequential adaptation. But what does sequential adaptation mean? Well, when you remember, we are fine-tuning we can also fine-tune a model for a cross-lingual model, or a model that knows a lot of different languages. We can transfer that to a language that we care about. So there's, for instance, the BERT model we spoke about before, there's a version of it called MBERT, and that's the next bullet point, which is how we built Abana, the tree for BERT model I showed before. We started with a BERT model that knew 100 languages. That didn't include any of ours, but it included like Yoruba, it included Swahili, I think. That might have been it in the first iteration. And so even though it didn't know tree, it knew an African language, which is not tree, but is closer to tree than English is. All right. And so in addition, it knew a lot of other languages. So it knew a lot of things that are common perhaps across languages. All right. So learning a new language is easier for that model than starting from scratch. Right. So that's how we built Abana. Now let's say you built Abana for Asante tree. In order to build Abana for Equapim, it's okay to start with the Asante tree model to build the Equapim, because the Asante is closer to Equapim than all the languages in MBERT, right? So sequential adaptation says, once you adapt, let's say, a general model like MBERT to one language, maybe a related language, you shouldn't start from MBERT again, but you should start from the new point, right? So sequentially adapt the models. So I think, for instance, our Dagbani model is a better starting point for Gorne than, say, blank slates, obviously, right? Because they're in the same family. They're different languages, but some people argue they're mutually intelligible, which means if you are from one area, there are certain things that you will understand, right? So that model, the Dagbani model, already knows something about Frafra that's useful. So we start with that instead of starting from scratch, right? That's sequential adaptation. And there are parallels to this in speech as well. So the models that tends to be used nowadays is Wave to Vec 2. And the ideas I just discussed about text are very similar there. You pre-train the model on a huge amount of data from different languages. It knows a lot of different things. Then you adapt it to any given scenario. Even if the initial models, languages it was pre-trained on did not include yours, it's likely there's in there something that's very useful for you. Right? So we use this to build Tree, Yoruba, and Ga ASR at the moment that you can try it out. So I think I answered. I apologize. But yes, this is actually the end of my talk, I believe. Is it? Yes. No. Oh, okay. There's this business analytics example that I could also address, but it's maybe extra at this moment. So I will end the talk by putting up the link to my book repo on GitHub, where you can get all the code for free to try some of these methods. If you are interested in buying a copy, it's on Amazon. There's a discount code, but I really do think you can get most of the value from just the code. If you have any questions, you try this stuff and you want to reach out to me, here's my link tree. All my contact info is there, social media, reach out, tweet at me. I'll happily discuss with you what you're reading, what you're working on, hopefully say something useful. All right. So at this time.
All right, thank you so much, Paul. It's been a very wonderful time here with you. And we are very glad that you have been able to share with us a lot of things to look at and what is actually going on with your projects here in Ghana and so on. It's quite enlightening. And I'm pretty sure that most of us here are beginning to now get interested into looking at this subject area critically and to see even how you can also contribute, especially to this whole concept of building our own language data set and all that, right? Great, so thank you so much, Paul, for that. We'd love to have you even time again, but for the sake of time, we have to end here. But I would want to give the opportunity to at least 3 it's okay if it's a little bit out of the topic of discussion, but if it's in line with aspects of machine learning or artificial intelligence, that's also fine. I'm sure Paul will be able to help out. But I hope it doesn't get to the level of a personal question. So yeah, so let's hear from you. If you're ready to ask a question, you can raise your hand up and I'll give you the permission to unmute and ask your question. Okay, so let's see. Wow. I don't see any hand up yet. Interesting.
There is a hand up, actually.
Okay, cool. Please talk. Collins.
Okay, yeah, so this is Collins.
Yeah.
I'm a biomedical engineer, and recently I'm growing a lot of interest for data science and machine learning. And I wanted to find out how long would it take for me as a beginner to really master to the level that I can assist this project that is going on, because I'm really interested and I would like to support.
Oh, you mean Ghana NLP?
Yes, please. I just started Python and some other courses.
Okay, great. Thank you so much, Colin. Over to you, Paul. Yeah.
Yeah, so you actually don't need much to start contributing, right? So there are tasks in our group, there are tasks like even testing the app, right? So the app has a submission field where if you try something and it's wrong, you can submit the correct translation, right? So the idea is so that they can continue improving, right? So even just testing it and suggesting some corrections, that's already very useful. The next step, once the suggestions are made, is periodically we look through that to correct the suggestions and to build the data out of it so that we can train the model on it again, right? And so reviewing the suggestions is already something that people join and they can start doing. If you speak, obviously, if you speak a Ghanaian language that's in the app already, then you can start doing that. If not, then you can help us start building a data set for a language that's not there, the first one, all right? So that's the direct, easiest way to start. In terms of machine learning methods, there are other groups that, apart from data, of course, we all contribute to the data, but there's also, machine learning methods that we are interested in pushing, like Abana and so on. And so we have different groups that handle, depending on the class of methods. So like translation is like a supervised approach, and then Abana maybe unsupervised, some kind of arbitrary divisions like that. And there are groups that study this stuff together and work on actual projects. So I would encourage you to start working on projects, right? Because machine learning is an extremely empirical field, right? You may not get that impression when you start reading the books, but really it's about being able to, produce the insights that we can iterate on, right? So we don't have as much theoretical deduction as we have empirical confirmation of intuition. So you have to run numerical experiments, generate the data, and analyze it. So just start running some experiments. So start with some, classification methods, start with some regression methods, then move on to something like summarization, ideally in a real context, right? So a real project. But even if without that, you can start on Kaggle. Kaggle, you're going to have a lot of example notebooks. I shared my link before of the code on Kaggle. The reason you want to use Kaggle is because then you don't have to install all the libraries and stuff on your own computer, which can be very difficult. It can take a lot of time to get it right. It's a skill you should have as a data scientist, but when you're starting out, it can really slow you down. So starting with Kaggle, and you can find many examples. Like if you're looking for SVM classification, right? You just search for that on Kaggle. Many examples will come up. Or if you're looking for text summarization, and then you can just click, copy, and run. Right? This is, once you are able to run it, just go through the steps, try to understand. If you, with enough experience, you begin to see how these problems are solved. So I hope all of this was useful.
Yes, please. It was very useful. Thank you so much for your time.
Yeah, we're still receiving more questions. You just raise your hand up and I will call you in. Okay, Sapon, can you please talk? I see your hand up.
Thank you very much for this opportunity. I've learned a lot so far. But Akatiche Paul, I also completed OAS. This is just to let you know. I want to know, how long have you been in this AI and how long does it take to see results? Because I've also been in AI, therefore getting to 2 years, and I don't really see enough improvement in me, like what you are doing here. So how long does it take, and how can I grow in this field? Thank you very much. Yeah.
Sure. It's a very good question. And I'll answer it through my experience. I also had difficulty breaking into the field, I would say. When I was in my PhD, I told the story about it, was kind of in optimization. And even though it was optimization is very similar to machine learning in many ways, and you think you have a PhD in the area, it's computational methods, you know how to code and stuff, you would think it would be easy, but it wasn't. So the problem I had when I started was people said I didn't have experience in the particular thing that they were interested in, right? So if they were trying to do computer vision, I hadn't worked on a big computer vision project. I'd worked on a lot of computational projects where obviously I could do the work, but they would tell me, you've not worked on computer vision specifically. So sorry, all right, we have somebody else who has the experience. So this is the experience you're gonna get. It's kind of like a chicken and egg problem when you start. People want experience, but how do you get experience if they don't hire you, all right? So the way I got into it is I broke through startups. Startups don't tend to not have the same bar, or like ridiculous bar, like say Google or Facebook or something. Those guys have all this, coding on whiteboard and all these things that I think are irrelevant to the job. But all these things kind of like, because they can, they'll put you through them, and then it's like this competition. Whereas there's a startup that needs you right now that is not gonna waste time. They need somebody tomorrow, you understand? Someone who can do the job, obviously. And when they see you're ready, they just go. So that's what happened to me, right? There was a startup, I just knew about them. I walked over there, they looked at me great. The next day I had a job, right? So sometimes it's finding like those kind of opportunities instead of thinking, oh, all of you have to work for Google or Facebook. That's not the case. There are a lot of opportunities out there that once you take that hat off, you will see them. And once you get that first experience, then the Googles and the Facebooks, they'll come running for you, right? And at this point in time, my difficulty is they spam me, right? I don't want to hear from them. That's my problem, right? Once I got the experience. So what I'm saying is you need to get experience. One good, and then your problem, I'm kind of deducing maybe that's the problem you're having. And the experience, you can either get it from like a startup that's not as picky about its candidates, or you can get it from like an open source engagement, right? So an open source project, that's another way. So like Hugging Face, right? They have all these opportunities at Hugging Face, where all this open source contributions you can be making, all this research you can be doing. Once that stuff is on your resume, it makes it a lot easier, right? And this to get open opportunity to another project, and then another project, and then from there, once you have another, you're not gonna have a problem. So that's what I would say. I hope that answers your question. If not, is that the kind of challenge you're having breaking into the field? And also, I mean, I guess you should be a bit patient with yourself. It can't take many years to like fully understand the stuff. Like I didn't start doing machine learning proper until after my PhD, right? And then when I started, it took me probably a couple years of doing it before I really got. So even some of the simple things you think you understand, right? You probably understand what overfitting is, but after running, your neural nets for 2 years and training in different scenarios, that's when you really begin to understand what works in practice and what maybe is just a theoretical thing you say in interviews, right? So also just be patient with yourself and keep going, and everybody's journey is different. That's the other thing. I've known people in acting, from acting, right? Their degree was in acting, and they're now, famous computer science practitioners, right? So not everybody's path is the same. Don't be discouraged. Don't compare yourself to others. Just keep going. And I hope what I've said is useful. If not, clarify.
Yes. You've answered all my questions. Thank you very much. So
Awesome.
I guess I have to get the experience from startups, then also show myself out and be
open source.
practicing on cargo. Yeah. Thank you very much. Thank you.
Yeah.
All right, great. I mean, I felt like throwing in a meme when Paul goes like, yeah, they spam me. The big companies are chasing after Paul, and then anyway, the wish of many.
They spam me now. When I wanted a job, they didn't. You know what I'm saying?
That's
I don't want it now.
Yeah, but just All right, great. So can we receive more questions? All right, Paul, now it looks like we have more questions. We'll take it one after the other. Benjamin, can you put out your question, please? And then right after Benjamin, Abdul Rashad, you have the opportunity, so it follows in that order. All right, let's hear from you, Benjamin.
All right. Paul, we thank you very much for such a wonderful presentation. In fact, when I hear of machine learning, it's something interesting, but from your presentation, I realized that there's a lot more I need to do to be able to get there, but I'll still try. Those of us who are trying to do our thesis in relation to the machine learning, and like you said, it takes a lot of time to be able to get the concept very well. I'm just wondering how we'll be able to manage our thesis, which is time bound, and at the same time, trying to get a concept of the machine learning. I don't know if.
Is your thesis very applied? Are you doing a lot of experiments as part of your thesis?
Come again.
Are you doing like numerical experiments as part of your thesis? Is that a big part of the work that you do?
Yeah.
Yeah. So, I mean, I think the solution is to try and merge the two, right? So if you can, if there's still time to change the direction, or maybe not change the direction, but just enhance the direction of your thesis so that it involves more applied experiments, right? So things where you're using, right, Python, you know, some famous frameworks to solve an actual problem, right? Then as part of your thesis, you can be getting the experience that will land you the next opportunity, right? So in my experience, when people hire, right, if your PhD work, if during your PhD work you did those numerical experiments that they're looking experiencing, then it matters a lot.
Okay.
Right?
Okay. Yeah. That's fine. So what I'm getting is maybe I can look at something like Python to design something, and then continue with the machine learning concept.
Exactly. Just make it relevant, right? Make that that numerical experience relevant to your thesis and do them together.
Okay. Thank you.
Okay, Rashad, over to you.
Okay, thank you, Doc. First off, I want to say a very big thank you to Dr. Paul for the huge pool of knowledge he has shared with us today. My question to him is, most often in trying to acquire knowledge about these various areas of technology, most often the struggle is where to begin and the direction to take. So what I would like Dr. Paul to share with us is, as a student trying to delve into the area of AI and machine learning, if he could summarize for us where to begin, or through his journey, where he began and the path he took, the various resources and whatnot that he had to go through to get to where he is today. That's my question. Thank you.
Yeah, thank you for that question. Yeah, so as I was saying earlier, during my PhD, I actually couldn't break into the field. I tried, I couldn't. So I was working in optimization, which was very close. It's close in terms of the ideas, but it's very different in terms of the actual day-to-day stuff you do. Like in optimization, you may do more pure math proofs and stuff like it's more theoretical. You may not have used Python before. You were using some other tool, maybe C or something. So, or MATLAB or something like that. So there definitely was a mismatch, which was the reason for the reason why it was hard for me to break in was there was a mismatch in the skills. Even though you could make the mental leap that I could learn it on the job, most people prefer you've already demonstrated that you can do it, all right? And so it was after PhD, as I mentioned earlier, I got in through a startup which didn't care about those things. They could tell I can do the job, so they're like, do the job, and I did it, right? And once I did that, you know, in terms of breaking into the field, it became very easy. From there, the problem was, you know, the spam, right? But in terms of resources, right? So once I started working in the field, what I recommend, again, this is something that's already come up. I recommend you start with Kaggle or the other resources, what do they call it? The Google Notebooks, Google Colab, right?
Yeah.
So a tool like that, you know, a lot of these models need a GPU or something like that. As a student, you're probably not going to be able to afford an expensive one. You also can't afford cloud computing, probably. So use one of those tools that gives you access to GPUs for free, right? Additionally, Kaggle is a very great source of information. So for instance, and where do you start? Start. Okay, that's the answer. Start on something. Think about what is the most exciting problem that I care about that I would like to work on. Actually, in machine learning, the first problems I worked on wasn't even, they were not even natural language processing, right? So when I started, I remember working on some competition just for detecting diseases on the leaf, right? Just because I thought it was interesting. I thought it's something, you know, maybe if I came up with a good solution, I could even build an app somewhere where I'm from, right? So it was interesting to me for that reason. And so that's where I started. And so when you really take a project like that, right, where it's from the beginning to the end, and you really invest time to understand every single step of it, your mind really transforms from like those toy problems that you may have solved. Of course, start with the toy problems like IMDb, sentiment classification, like all those things that many people have solved so many times. You know what the answer is, right? Start there to learn the concept. But really, one that's really going to transform you is something like a Zindi competition, right? They have a lot of nice ones there now. Work on some of those. And I guarantee you, if you spend, let's say, a year solving 3 or 4 challenges on Zindi or Kaggle, and like really not knowing the answer and like competing maybe to encourage yourself, don't worry about winning or anything like that. Just try to do well. And you will see that even a year after, your ability to solve real problems, right? And even problems that you may not know anything about, right? There's something beyond even knowing or the different steps of a machine learning problem specifically. Just how do I go about solving problems, right? I installed the software in the environment that I have to use, let's say SageMaker. I never used SageMaker before, but how do I go about learning to use it very quickly, right? Or when I run into an issue, how do I go about troubleshooting it? Those are really the things that I think those are the real things that make you valuable. Because that's in the real world, those are the things you're doing every day. You're not running around proving theorems or something like beautiful mind. That's not what people pay you to do. People pay you to solve problems, and so you're going to run into problems. How do I troubleshoot and that only comes from experience. And like a problem like Zindi, Kaggle will give you that. Yeah. So I hope that's a useful answer.
Very useful, Doc. Thank you very much.
Yeah.
Okay, great. So, Emmanuel Aduchum, you can go ahead with your question.
Yeah, hello. Please, thank you very much for this great opportunity to also be at this session. And I'm into computer programming. I have some knowledge in Python and R programming, and also some little knowledge in Java. So I would like to know whether for this project, I can also be a team for this project with the knowledge I have in Python and R programming and also Java. And
yeah, I mean, in machine learning, right, it's not just building the model. That's important. There's a whole part DevOps, right, and deploying it. That's probably even arguably more important, right? That's what people would say. So if, for instance, if you tried our app, you will find that the text translation is a lot faster than the audio, the text to speech, the speech to text, right? Because obviously transmitting the audio and then inference is more expensive for the audio than it is for the text. It's a bigger file, right? So building a system that doesn't break when thousands of people try to use the system at once, building a system that responds very quickly, functions very quickly, designing the user interface so that it's very easy for the user to even see how to use it intuitively, right? These are all extremely valuable things that go beyond machine learning per se, all right? So app development, deployment, monitoring, and response times and all of that. So yes, Python knowledge, Python is one, good to know Python and some of the other languages you mentioned, and you may have to learn others. And cloud is a big part of it, right? Knowing how to do these things in the cloud, how to manage the servers, how to try new app services, and even architecting, right? Figuring out which services we should use for any given feature, looking at the cost of it and finding, the most cost-effective way of doing it, right? These are all things our engineering team at Ghana NLP does that. So please feel free to join. There's a lot to do in that space.
Okay. So, and also, I want to know where I can purchase the app. I realize it's not for free.
Which app do you mean?
I mean the Kaya Pro.
What do you mean it's not free? It's on Google
Play Store. Oh, okay. The
Google is on iOS.
If
you want to purchase an ad-free subscription to support us, you can do that from within the app.
Okay, sure. Okay,
Yeah.
sure. Thank you very much.
Yeah, thank you.
Yeah, great. I have Kaya already on my phone because I love, doing stuff with it. Usually in my write-ups, when chatting with friends, I want to have the Ghanaian language pop-up, Anyway, I need to get an iOS keypad. But hey, Paul, I've not found one yet. I don't know whether there is
there are a few of them actually. There's one called Swift Key. There's one called
Swift Key, right?
Swift Key. That one is from Microsoft. There's one called Gboard from Google.
All right.
There's also one called Keyman. Keyman is also available on Mac and Windows.
Nice. So, then I'm going to look up for them. Anyway, great.
We'll put we're actually working on like some tutorials and putting all this. So I will share them with you once it's ready.
That would be fantastic, Great. So I love to see the massive development we are having in our part of the world, because the thing is, if we don't do it, nobody's going to do it for us. And it's great that Paul and the team have started this, and we're looking forward to seeing many of our students also join up in the team. I really do encourage all of you guys here to show up to help, because it's an open source thing and we can contribute so well to it. So Vinny, can you put up your question, please? And after Vinny, Joshua Rexmond. Okay, so Vinny, over to you. Hello, Vinny. Is Vinny here? All right, let's move on to Joshua. Joshua, are you ready? Or Vinny is up now? Okay, Joshua.
Dr. Paul, please, I want to ask you this question. Okay, so as a student who is trying to break into tech, let me say AI or data science, for instance, and in school, I see, for me, instance, I'm studying statistics. So do you think between my books, like the normal study here, and maybe me learning like outside things, like me learning maybe Pandas, Seaborn, maybe Matplotlib, which one should I focus like more on? Which one should I spend my time more on? Should I spend my time learning the maths or learning the tech things?
No, you definitely, I mean, you're in school for the math, right?
Yeah,
So
okay.
you,
Actually, I wanted to do data science, but we don't do data science as in like undergrad course in Ghana, so I
yeah,
chose. Yeah.
no, you definitely, you probably should, not probably, you definitely need to focus on the math for now, right? Make sure, you study and like you pass all your stuff correct, because in machine learning, people come from all sorts of fields, and statistics is an amazing source of people. So once you do that well, it will open doors for you, right? So that's the reason not to abandon that. But in terms of, but definitely you want to be learning the Seaborn and the Python and all of that as well. And not, as I was saying earlier, not just learning it on your own in a corner without an actual project, all right? So that's where the real value is, because when people interview you for their positions and stuff, they do distinguish between just some academic experience and the academic experience in addition to like real practical demonstration that you can apply these things, in the field, right? So somebody who has solved some toy problems from a textbook may understand the concepts very well. But when you put them in the field, you tell them, go install TensorFlow on SageMaker, and you leave, they're not able to figure it out, right? Because there's more than that goes into the process of doing that. Like just of picking up a new skill you may not already have, right? And that comes from experience. So that's why I like to stress all the stuff you're doing, you should keep doing it, but make sure that there is a real project that you're trying to apply this knowledge to in parallel. Whether you do an internship, if you can get an internship, do one. Whether you can join an open source group, there are so many. Ghana NLP is not the only one. There's so many now. There is Python Ghana. There's Masakane doing NLP on a more Africa broader scale. Data science. I can't even. There's so many. Okay, so just joining one of them and working on some real projects. It's a lot. It's just going to teach you something more than the classes and the other experience that you're talking about. That's very important to become fully rounded applied data scientist. So I hope I answered your question. Definitely keep doing, keep doing the statistics. It's useful.
All right. Thank you so much, Paul. I think we'll just take our last question. Maybe if Vinny is up, then we take it from Vinny. Then maybe we can end up here. We almost like 2 hours into time, fan. Thank you, man, like for staying along. And thank you for your time, Paul. I mean, I really do appreciate it. Let's see, Vinny, are you up? Are you ready for? Okay, Vinny is still not up. Thank you all, ladies and gentlemen, for joining this session. I mean, it's been awesome 2 hours with Dr. Paul. Yeah, we'll start making conversation and see how we can have a great partnership with some of the projects you are doing here in KNUST. We've seen over the years a great interest of some of our students into the field of machine learning. Let's call it data science particularly. And we hope to be able to fill the gap to enable our students get the great experience so that they can be useful, especially to deal with social problems here in our country. So very, very glad. I'm really interested in your project, and I'm sure you know, and that's why I linked up with you for this session. We'll be following up with you and connecting again. Thank you all so much for joining, and we would like to end here. I don't know if you have some final words, Paul, to share.
Well, thank you for having me. I always enjoy talking about this stuff. I hope I sparked some ideas in some future minds, future leaders. And I would like to encourage you to keep your eyes open on potential applications of this stuff. I think it's like what a time to be alive, literally, because a lot of technology that you couldn't even imagine 5 years ago, it's at our fingertips now. There's so much opportunity for so many applications that could benefit society, first of all and foremost, but also for you to make a career as an academic or an entrepreneur, whatever you're interested in. So it's exciting time, and don't be left out. Keep your eyes open, and I'm sure we are going to do amazing things together.
Okay, great. Thank you so much, Paul. You can link up with Paul on LinkedIn, and you can link up with me as well on LinkedIn. My name on LinkedIn is Emmanuel Ahene, and Paul is Paul Azunre, right? Good.
Yep.
So thank you all so much. Some other time we will schedule the next webinar for all important reasons. Okay, thank you so much, Paul, and bye-bye.
Cheers. Have a good one.
Thank you, Dr. Paul. Thank you, Dr. Emmanuel.
Thank you all.